Hi everyone. First, I would like to take a selfie with all of you. Normal thing now. Say hi. So my name is Luis Ascorbe. I'm from Spain. I live right now in Barcelona, and this is my Twitter handle. Just in case you would like to, shout at me any question after a talk, or just ping me or talk to me about anything. I've been programming for the Apple platforms for the last 8 years, and the last 5 years I've been a iOS lead at a company called Wallapop, based in Barcelona. And on my spare time, I also organize a small conference in Spain. It's called NSSpain. And I have some stickers. If you would like to get some, just come and talk to me after the talk. So today, I'm here to talk about the journey of how me and my team went from a monolithic app, a monolithic project, to one where we use modules. So how we split it, right? But before we get started, I want to tell you a few considerations. So the first one is that I'm no longer working at Wallapop. I quit a few months back. Right now I'm on sabbatical time, enjoying life. And the second thing I would like to tell you is that I didn't do all of this myself. This was a team effort, so the credit belongs to all of them, not just me. So let's get a bit into context here. We were working on a really big project. We have like 700,000 lines of code without counting the third-party libraries. We had 86% of Swift and 14% of Objective-C. We were eight iOS developers working on the company, and we were spread over 6 cross-functional teams. And as you might know, when you work on a big project and you're kind of a big team, you start running into problems, which are like normal beat time. I mean, it was not crazy. It was not like 10 minutes build time for the app or the project, but we were around 3-4 minutes, which is a bit cumbersome. It doesn't let you, work on certain ways, like applying TDD methodology or things like that, right? It was not crazy, but it's not great. Then we have the scalability of the project. With a project so huge, it was hard to maintain, to create new features and add new code, change code all the time, especially if we get in mind that we were 8 people adding code to the same code base. And then we also have the problem of the scalability of the team, meaning that there are new people coming into the team. We were growing, and it's hard to decouple all the code inside a project like this. And one last warning I want to give you is that this is our story. You'll see how the process went. But what they want to tell you is that before taking any actions, you have to consider the options you have and get the best one that suits you. So, what's the story? This is the timeline we are going to be walking through during this talk. So we are starting on June 2017, and we are going forward until today. So let's start by June 2017. As I told you, we had like a huge app. It was a monolith. All the code was on the same project. But before we keep going forward, I'm going to maintain a timeline here at the bottom, so we all know where we are. So as I told you, the project was big. It was a workspace. This is because we were using CocoaPods. So the project started before Swift was announced, and we started it with OJTC, of course. So what CocoaPods does is it creates a workspace which lets you, add dependencies easily. All those dependencies are static Swift libraries, static OJTC libraries. And after Swift was announced, 1 year later, we started considering to add Swift into the project because we saw that that was the future, right? But if you remember at the time, if you wanted to add Swift to your project, the only way to do it, or the best way to do it, was with dynamic frameworks. And we couldn't add, so we wanted to add a couple of libraries to our project since we started adding Swift code, but we couldn't use dynamic frameworks because if we just change on CocoaPods from static libraries to dynamic frameworks, that will increase the app launch a lot, right? I don't know if you remember, but in 2017, with iOS 10, I think, or 9, it was, before that, so it was 2016. It was really hard to, well, it was the app launch was really bad when you had quite a few dynamic frameworks because the app has to link all of them on the start. So the way we solve this is we add a new dependency manager, which is Cardedge, to manage all the Swift dependencies. Yeah, you heard that right. We had not one, but 2 dependency managers. So Cardedge for dynamic frameworks with Swift, and CocoaPods for OJTC static libraries. If you want to know more, there was a nice talk yesterday by Omer, which was bringing me to life a tale of Dalib and how iOS launches your app. So as I told you, it was a good time. The project was not perfect, but we could develop everything without any problem until something happened. Remember, we are on June 2017. So the thing is that we ran into a Swift compiler bug, which is the argument list too long. What does it mean? So what the Swift compiler does is it takes all the absolute paths of all the Swift files you want to compile in one project, and it puts all of them on the same command. And when that command exceeds the system limit, the Unix limit for the commands, you get this error. So it doesn't let you compile the project. And so we were like, this is really into the system. This is into the Swift compiler. We cannot do much to fix it. Just wait for Apple to release a fix. But we had a quick fix to apply to the project because this was happening locally. The CI server was still working okay. So the quick fix was changing the path of the project to a shorter one. And it worked. We solved the issue. We could compile again, well, more or less, until the CI exploded. And since we were using a third-party CI server, we couldn't change the path of the project ourselves. So what you have to get from this is that you can apply a quick fix, but you should have a long-term plan. So we are back to our timeline, and this happened in May 2018. Remember, we have a big project with Garage and CocoaPods. So we start thinking how we can solve this. What was the long-term plan we can commit to overcome this issue? And so we create new modules. And the way we do it is creating vertical frameworks, vertical modules for each feature that we build inside our app. Having UI domain data, which are the layers of our architecture. And we started by the data layer because it was the easier one. We just have to move all the data models to the outside, which are decoupled from the rest of the code. So it was a quick win. But the CI broke several times on this process. Remember that we are on a team. You, of course, have to keep developing new features. You still have to change code. You have to fix bugs on production. You have to continue working on what you're doing, right? Meanwhile, we have to deal with this issue with the compiler bug. So the CI broke, then we moved some files and we fixed it, then the CI broke again, then we moved more files. So we keep moving files out of the main project to those modules we created, which were just a couple of them. But to buy us more time, we thought that we needed a way of overtaking the issue faster. And that means creating horizontal models. So instead of like having a feature model, let's say delivery, right? You send packages from one place to the other, and then you create a model with the code that only does that. And then an horizontal model means like an API client or a domain layer or a data layer, right? Since we already had this architecture in the app, it was easier to go that way. So we created three models, which are the API client. It was super easy to just extract all the API client and all the data models related to that that part of the app. The domain model to which we only extracted the business logic models. And another model that we call common, which we put all the helpers, common helpers, and common models that we use on the app. And as I told you, meanwhile, we keep developing new stuff, doing more stuff, and we are on 2018. So of course, Apple releases Xcode 10, a new iOS SDK, and then we also have to, support the new Xcode and do the changes needed so the project works on iOS 12. But something good that brought Xcode 10 is that we finally can use Swift static libraries. And when CocoaPods supported this feature, we started to think, hey, maybe we can get rid of cartridge. So we are back to our timeline, and we are now on January 2019. So, well, you can barely see that shit is coming. So we're back on our project. You have a couple of feature models. We have 3 horizontal models. We have cartridge. We have CocoaPods, and we kind of solved all the issues. Everything was working more or less fine. We were good. So we said, like, hey, we are really good. We are smart iOS developers. So let's not only get rid of cartridge, but also take all the modules and put them in CocoaPods. So we only have one thing. We don't have cartridge, CocoaPods, and Xcode projects. And we did it. We moved everything to CocoaPods. So we have all the dependencies in CocoaPods, all of them being compiled as Swift static libraries, and all our models being development pods. And we were super smart. Yeah. It was working fine. We were happy. It was really good. It exploded in 1 week. We got the same error again. But instead, so this time instead of breaking the project, the main app, it was happening on the pods project. Because since we moved all the modules project to the pods project, when CocoaPods was trying to build all the project with all the development pods inside, we were again reaching the Unix limit for the command when compiling. But the good thing is that this was happening on the CI server, not locally. So we kind of we were able to keep working while the CI was still broken. And now we are on again to our timeline. This is February 2019. So when this happens, we start to think. This is not the way to do it. We have to get back to the long-term plan that we planified, and we have to really think if this is how we want to do it. So we had a list of all the requirements, and we have on the problems we wanted to face, and this time we wanted to solve it for real. So we also talked with other engineers. So we are iOS developers, we are macOS developers, we are Apple technologies developers, but there are also Android developers, front-end developers, back-end developers. We are all developers, we are all engineers, and we all have the same problems. We all have the same problems with dependency injection, we all have the same problems with modules, and probably your colleagues, your peers, had problems like those, and maybe they solve it on a way, or they have a point of view that might help you. And it did for us. Talking to them helped us look at the problem from a different perspective. So we are back to our project with only CocoaPods. Remember that it's working nicely locally, but it's broken on the CI. And so before removing cartridge, we had this nice configuration of Xcode projects for the modules we had, and then CocoaPods for several dependencies of our own and third-party dependencies. And we liked both solutions. So we thought that the best way to overcome the issue was to maintain CocoaPods and also create different Xcode projects for our own models. and we did it. So we, again, move all the models we had on the development pods into Xcode projects within the workspace. And remember that means 3 horizontal models, which were the API client, the domain with the business logic models, and the common model with some helpers and other stuff, and a couple of vertical frameworks, vertical models, sorry. But this time, we wanted to really tackle the dependency between models, which was a pain point. So we introduced something new, which is the interface. What's the interface? It's just a plain protocol that exposes the public implementation of your model. So it's easily mockable, easily accessible from the outside, and you don't have to know anything about that model. So it removes the direct dependencies between models. And to put you on an example, we have models, we have CocoaPods, and then we have the project A, which the interface A. So the interface is like what you can see from the outside. We did it this way because between models, you cannot. So one model cannot see the other one. They cannot be seen between them, right? But anything we had in CocoaPods can be accessed from the project or from any model. So imagine that, for example, we have the module item, and it exposes the item interface, but it also knows about the user interface. And then we have the model user, which is exposing and knows the user interface, and it also knows the storage interface because it has to save some data or the session, whatever. So this is nice, right? But we need a way to manage cycle dependencies. And this is where the main app comes in. The main app is the one that knows everything and is the one that connects all the models. So it mainly does 2 things. One is that it holds dependencies. So it acts as a dependency container. To show you how it looked, we created the dependency container, then we register the interface with one module, and then we resolve that dependency, which is going to return you the module. So let's take a look into this part exactly, which is the second responsibility of the main app, which sets up models. It works this way because each model implementation has to define an init method, which is how we did dependency injection through the init. If you would like to know more, there was a nice talk yesterday by Paul Hudson on how you can overcome this issue in a different way. But wait, so what happens with circular dependencies? So let's imagine that this is a typical case. We have user, and user depends on item. So you have the model user, which depends on the model item, right? Because you want to open an item that the user has, something like that, from the profile. And then we have item, which depends on user, because you are showing some user info within an item view. An item view. And the way we solve this is with a nice Swift feature, which is just the auto closure. So what it does is when we are resolving the dependency, we are declaring it like this, but instead under the hood where you're passing is a closure. So you are not passing the model at that exact point in time, but you are going to get it when you are going to really use it. Another issue we had was with the models. So we had two ways of, so the thing is that from user, we want to use, for example, the item model, and from item, we want to use the user model, right? And so you have two ways of doing this, or we had two ways of doing this. One is we declare the models inside the small pod that declares the model interface, or we can have a separate model or pod with all the other models that can be shared through all the modules. And we went for the second option. So on the project, so we are back to our current implementation. And so we have the modules separated, we have CocoaPods. And there is still one issue, which is how we keep moving code from the main app to the modules, and how we keep decoupling and extracting all the code to those modules without getting too much trouble. And here's where the legacy interface comes. And what's the legacy interface? It's an interface for the app. So whenever you want to access something that is in the app, you have just an interface, so the module doesn't know about the app, but about the interface. We declare it as a development pod. So all the modules know about it. And whenever you need something from the app, you just inject the app, but the model only knows the interface. So if, for example, we extract the model user, but user needs something from delivery, and delivery is still in the app, we just declare that only thing that user needs. That way we can keep working and extracting things from the main app into the modules, but without making our own modules know about anything else. This has a downside, which is it can be overused. You can be working on this and just add all the stuff you want on the legacy interface, right? And the way we were trying not to add too much stuff on the legacy interface was through pull requests. So we checked others' code to not overuse this implementation. At the end, we all wanted to make the project better, so it was not a big issue for us. Now we are back again to our timeline, and now we are at today. So all these solutions worked for us, and we solved the main problems we had. And when we made those changes, what happens is that when we worked on the modules, the build times were a dream come true. Imagine coming from 3 minutes to just a few seconds when you are working on just your model. So this is how the structure of the workspace looks like. So we have the main app, which had all the code, which we tried to extract into modules. Then we have all the modules that we created. So this is a screenshot from a few months ago. Probably it grew. And one thing I would like to say about those models is that each one of them have an example project inside. So when you work on just one module, you compile a separate project which mocks all its dependencies, and is much nicer to work that way. And then we have the pods project, which had the small interfaces, the modules that were shared between the models that were shared between the modules, a couple more dependencies of our own, and all the third-party code. So to sum up, those are the conclusions. Remember that there are no silver bullets in software development. This was the solution that worked for us, and as you saw, we didn't have this implementation overnight. So it was a 2-year process where we kept improving, keep changing things, keep looking into what was working, what was not. You have to ask yourselves if you need modules, because as you can see, it really increases the complexity of your project. You have to commit into long-term plans and really think of how you want your project to be in the future. If you're working on a big project and you want to modularize it, start small, as we did. For example, with the first modules. So we didn't move the entire module outside of the app, but we did it on a small steps. Like first the data models, then just start migrating other classes, and etc. And last but not least, discuss with your peers. Talking with other engineers will broaden your horizons. That's it. Last, I would like to thank my team, Aitor, Alberto, Alex, David, Philip, Gerardo, Isaac, Mario, and Tim. They were the ones that work on all this. And I would like to also thank Raquel, which is the designer, is a designer at Wallapop, and she created all the cool artwork for the presentation. Thank you very much.
Thank you. All right, we have so many questions. Obviously, we don't have time to answer all. Okay, you get to pick which one you want to answer.
So, does each module have tests, unit tests or UI tests? Yes. It depends on the module, but it can have both. As I told you, we had an example project, so as you can compile that separately, you can also run tests for each one of the modules. So what we have is we have one scheme, one Xcode scheme that run all the unit tests and all the tests of all the projects, all the modules and the main app unit tests and integration tests and UI tests. And then if you would like to run one set of tests of one of the module, you will pick the scheme of that exact module or that exact section of the app. What are painful things or common problems that often occur on your team when we are migrating to modular? This is a hard one. So I think the hardest thing is to balance how much work you put into extracting stuff and working on the structure of the project against creating new features and fixing stuff within your project, which is a hard thing to do. In my opinion, you have two ways of doing this, which totally depends on management. You can have one team dedicated to this, which is usually called core or platform team, which of course are going to have metrics and objectives on how to improve the project and how to make developers' life better. And then you have another option, which is all the product teams must tackle the problems that the project have and must work on the developers' tools that all the teams use, which was our case. In that case, you have to talk to your team, and you all have to be on the same page and understand that you have to work on those issues. Otherwise, you are going to have problems if you don't tackle them.
Just one more question.
Okay.
Which I also upvote.
What was the CI that broke so often? No, I'm not going to.
Okay.
How did you make a choice of CocoaPods over Cardage? So, well, the thing is that I really love CocoaPods. I think the people that work on it are really smart people and really nice. And it's a project that's been maintained for so long that I just trust on the future development of the project. That really gives me a lot of confidence over that project. On the other hand, I have to say that working with CocoaPods is way easier than working with Cardage. I was going to say that another good thing is that with Cardage you have binaries, so you can look into the code, but that's not totally true because you can link against projects. But yeah, I think it's just subjective preference. At the end, it just doesn't matter. Use the tool that you like best.
All right. Thank you so much.
Thank you very much.